L11. On L11, it's a little bit harder for me to kind of explain because it's a video and stuff, but let's see what we can do about it. Reflecting around a regular polygon. Now, this is going to make a difference whenever we have an irregular polygon. Now, a regular polygon is when all of the sides are the same length and all of the angles are the same size, okay? So, on most of these problems in L11, they're going to be regular, but sometimes they're not. Like a rectangle is not regular because a rectangle, it's all the sides aren't the same size for the most part. Or a trapezoid. Okay, so not all of them are going to be regular, but if they are regular, then we're going to use this information, and really this information right here. Reflecting a regular n-gon, and an n-gon just means how many sides it is, and it's a polygon. Across a line of symmetry carries the n-gon unto itself. If n is odd, so if the number of sides is odd, the lines of symmetry pass through a vertex and the midpoint of the opposite side. I'll explain that better in just a minute. If n is even, or if you have an even amount of sides, the lines of symmetry either pass through two opposite vertices or pass through the midpoints of two opposite sides. Again, I'll explain that in just a little bit. This is what we're really going to be using for the most part. Rotating a regular n-gon by a multiple, we're going to use that later on, but not necessarily at the beginning of the lesson, of 360 over n carries the n-gon into itself. Okay, now what does n represent? N represents the number of sides. 360, if you started one spot and you rotated 360, where do you end up at? At the beginning, right? So if we divide 360 by the number of sides, that's how many times we can, that's the degree that we can rotate it and get a same shape, because it's a regular polygon. Alright. Oh. My dog's wanting in the house. Let's see if she gets in there or not. Okay. Which of the following transformations carry this regular polygon into itself? So how many sides do we have? 1, 2, 3, 4. So if I take 360 and I divide by 4, we get 90. So if I rotate it 90 degrees either way, it's going to go to itself. Or any multiple of 90. Now what's a multiple of 90? 180, because if 180 is 2 90s, and so that just means I rotated it twice. Or 270, which means I rotated it three 90 degree times. Okay, so 90 degrees, rotation of 90 degrees counterclockwise, and a rotation of 90 degrees clockwise and counterclockwise. But then we have to look at this, a reflection about L. If I have L right here, is whatever's on this side a reflection of whatever's on this side? And the answer is no. The reason for that is because it's an even amount of sides, and if it's an even amount of sides, lines of symmetry pass through opposite vertices or opposite sides. So I'm going to erase all this real quick. So here, if it wanted to be symmetric, because it's even, I would either have to have a line of symmetry here, a line of symmetry here, or a line of symmetry through both vertices. That's when it's even. Now when it's odd, I'll explain that in just a little bit. Okay, so we're going to say we have 1, 2, 3, 4, 5. So 360 divided by 5 is 72. So if I rotate it 72 degrees counterclockwise, then I would get a reflection. Or if I multiply this by 2, I'd get 144, and so on and so on, okay? But I don't have any of those weird numbers on this. Now, but I do have to check the reflection across L. And again, whatever's on this side is not the same on this side. So I'm going to erase again. Where would its lines of symmetry be? Because it has an odd amount of sides, it would go through one vertex in the middle of its opposite side, or one vertex in the middle of its opposite side, or one vertex, you know, something like that. So there you go on that. One, 2, 3, 4, 5, 6. 360 divided by 6 is 60. Rotate 60 clock. Rotate 60 counterclock. 90 is not a multiple of 60 because if I do one more 60, I would be at 120. 72, nope. So it would just be those two. 1, 2, 3, 4, 5, 6, 7, 8, 9. 360 divided by 9 is 40. 40, not 36, and not 60 because if I have two 40s, I'd have 80, and I'd never get to 60. Now, what about the reflection about L? Okay, since we have an odd amount, it's going to go through a corner and an opposite side, which it does. And whatever's on this side is exactly the mirror image of whatever's on that side. So it is a reflection across L. Okay, first time, this is not regular. Because remember, a regular polygon is when all the sides are the same length and all the angles are the same size. Okay? So it's not regular. So because it's not regular, we do not... Oh, sorry. We do not do this in a roundabout way. Let's go back over here. So it's a trapezoid. And it will tell you it's a trapezoid and everything. So we just have to kind of look at it. And a reflection about L1. So is whatever's on this side exactly whatever's on that side a mirror image? Yes. Erase. But what about L2? Is what's on this side the same as what's on this side? No, because this goes like this, and if that was a mirror image, then it would look like that also. So it is not about L2. And let's see. And if I rotated it 180 degrees, then it would look like this. And they do not look this. That's what we're talking about. Making it onto itself, and it's not, and we can't do it here. Oh, time out. We can't do it 180 degrees because it wouldn't look like itself. Now this is a rectangle. It tells you it's a rectangle. And a rectangle is not regular because these lengths are different than these lengths. Okay, so reflection about L2. No. If this was on a piece of paper and I folded it across this line, these would not be on top of these. So they are not going to have reflections like that. And so we're not going to reflection about L1 or L2. But we can rotate it 180 degrees. If I take this point and I take it 180 degrees, then that box would be on top of itself. But if I rotated it 90 degrees, if I just rotated it 90 degrees, then it would be like that. So it would not look the same. So there's just a rotation of 180 degrees, either counterclockwise or clockwise. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it is regular because I know I've cut them out whenever I was doing these, but let's just say it's regular. So we're back to this. So 360 divided by 9 is 40. Okay, so I don't see a 40 there. No. L. It's a regular odd gone, 9 gone, and so it goes through a vertex and its opposite side. So this is the same thing as this, so it is a reflection here. But 270 and 280, let's check on this. Could I multiply 40 by something and get either 270 or 280? Well, if we know our multiplication tables, since they both end in 0, right? Could I multiply 4 by something to get 28? Yes. 7. I cannot multiply 4 by anything to get 27, so that's out. So what this is saying is, if I rotated it 7 times at 40 degrees, that would be 280, and I would be getting the same figure as what we started off with. So clockwise and counterclockwise doesn't matter. 1, 2, 3, 4, 5, 6, 7, 9, 10. 360 divided by 10 is 36. It's even, so it needs to go the line needs to go through both sides or through both corners, and it does not, so it's not going to be one of those. So what we're going to do to either see 216 or 324, I'm going to take 216 and divide it by 36 and see if it goes into it evenly, and if it does, then 216 is a multiple of 36. And then I'm going to take the 324 and divide it by 36 and see the same thing. I do not know the answer, so I'm grabbing a calculator. So 216 divided by 36 is 6, so that works. 324 divided by 36 is 9, so that works also.